In this video, I will be going over lesson 27, which is about the volume of 3D figures. So, with volume, you absolutely need to know your formulas. If you do not know these formulas and you do not have them written down, you will not get these answers correct. Again, you need to know your formulas. Once you have your formulas, you're just plugging in numbers, multiplying, and that's it. Okay, so formula for a rectangular prism, which is another way of saying like a cube or a box, is going to be length times width times height. So length times width times height. Okay, so just the three numbers normally that we're able to see. And a triangular prism is 1/2 your base times height times height. Okay, so 1/2, don't forget your 1/2. This is where I see a lot of students get this wrong because they forget the 1/2. Do not forget your 1/2. So I have my base here. I have the height of the main triangle and then also this other side here, which could be like your height of your base. So 1/2 base times height times height. So if you want to take a picture of this, have it written somewhere so you can always find it, write this down or do something, because I promise you knowing these is going to make solving all of these problems upcoming so much quicker. Alright, so here I want to know what's the volume of this figure. Well, I know that my volume formula for a rectangular prism is 1/2 base times height times height. I would also always suggest writing out this formula when you are doing these problems, okay? Because if you have the formula written down, the more you write it, the more you remember it, so it'll make solving these a little bit faster. Okay, so I have 1/2. My base here is 3. My height is 4. And my other height is going to be 6. And once I know that, all I need to do is type that into a calculator and it tells me my answer. So I have 1/2. You can also type in 0.5 for 1/2 if you would like. Times 3 times 4 times 6. 36. 36 centimeters cubed is my volume. And that's it. A bit easier than surface area. You might start recognizing some of these figures from the surface area lesson that we just did in lesson 26, but now instead of finding surface area, we're finding volume. So here we want to find the volume of the figure in cubic inches. So remember, always check your units. I'm given feet and feet here, so to change that, remember we need to multiply both by 12. You can type this into a calculator. When you do 0.5 times 12, you do get 6. So this is 6 inches. And when you do 1.5 in a calculator times 12, you do get 18. So my volume formula is length times width times height. Length is 4, width is 6, height is 18. Type that into a calculator and then we are good to go. 4 times 6 times 18, 432 inches cubed. So again, see how with volume, knowing these formulas is very, very helpful. So when you're writing these down and when you're solving these at home, make sure that you're starting with your volume and your volume formulas. Alright, next, so Raylan is finding the volume of this figure. It says that she multiplies 6 by 7 by 10 to get the volume of the rectangular prism. So she does 6 by 7 by 10, which is 420 cubic meters, okay? Then she multiplies the 5 by 7 by 10 to get the volume of the triangular prism, which is 350, and then she adds them together. So remember that I told you that the number one mistake that I see with students is that when there is a triangular prism, remember that formula is 1/2 base times height. I always see students forget this 1/2, and that is why they get these wrong. So her volume that she found for her box, the rectangular prism on the bottom, was correct. However, since she forgot that 1/2, that makes her get the wrong answer because she forgot the 1/2. So no, she did not find it correctly. She incorrectly found the volume of the triangular prism. So no, she incorrectly found the volume of the triangular prism because she forgot that 1/2. So don't forget the 1/2 when you are solving triangular prism problems with volume. All right, next we want to find the volume of the figure in cubic centimeters. So this figure, if you remember from surface area, was a bit of a doozy. There was a lot of different sides and they were almost all different, and it took us a bit of time. With this one, it's going to be a little bit easier because volume is just how much space fits inside. So all we really need to do here is break this into 2 different rectangles, find the area of each one, and then add them together. I'm going to break apart my rectangle right here. So I'm going to have this long, flat one on the bottom, and then this shorter, a little bit wider one on top. So let's do this bottom one first here. Okay, so I'm going to do the area, or the volume of this bottom one first. My volume is length times width times height. Here I have 14, 20, and 2. So 14 times 20 times 2. And then I'm going to do my other box on the top. So that's this one up here. So that is 4 times 2. This bottom side is 20, which means this bottom side will be 20. So, whoops. I have 4 times 8 times 20. Now let's type both of these into a calculator and add them together. So 14 times 20 times 2, 4 times 8 times 20. Add these together, 560 plus 640. That's going to give me 1,200 centimeters cubed. So the area, or sorry, not the area, the volume of this figure here is going to be 1,200 centimeters squared. Cubed, sorry. Our next question says that the base of a triangular prism, so what I'm going to start doing here is drawing a picture, and I know it's a triangular prism. So I'm going to draw a triangular prism here. So we have a visual. It says that it is a right triangle with a base of 20 feet, a height of 120 inches, and the height of the prism is 5 feet. What is the volume in cubic feet? All right, well, right off the bat, I see that 120 inches, and in my brain, I'm like, I need to change that to feet. To change inches to feet, we need to divide by 12. So 120 divided by 12 is going to give me 10. Okay, so that means that this side over here is no longer 120 feet, is going to be, or 120 inches, it's going to be 10 feet. From here, I'm just going to plug this into my formula. 1/2 base times height. So I have 1/2 times 10 times 20 times 5. The order in which you write these numbers does not matter because with multiplication, remember your order doesn't matter. So I'm going to do my 0.5 times 10 times 20 times 5, and I get 500. So that means that the area of my triangular prism here is, or sorry, not area, the volume. The volume of my triangular prism here is going to be 500 feet cubed. Again, drawing pictures is always helpful. Also, knowing your volume formula is incredibly helpful. Please try and memorize them. Alright, last question says that Jake has a shipping box with the following dimensions. Havana's shipping box is similar to Jake's, but each dimension is half as long. How many times greater is the volume of Jake's box than Havana's? So I'm going to set this up the same way I set it up in the surface area video, okay? And I'm going to do Jake over here, Havana over here, and then our final. I'm going to move this bar over here. There we go. This time Havana's dimensions are half, so instead of multiplying by 2, we're going to be dividing. So I would have 6 inches, 2 inches, and 4 inches. These are both boxes, so I'm going to do length times width times height. 12 times 4 times 8. Again, length times width times height. So that's going to be 6 times 2 times 4. Let's pull open a calculator to help us out here. So 12 times 4 times 8. 6 times 2 times 4. So I have 384 and 48. Similar to what we did on the surface area, we are going to be dividing our volumes. So 384 divided by 48, and whenever we divide them, whatever number we get is going to be our final answer. So 384, and we are dividing that by, whoops, not 24, 48, and we get 8. So that means that Jake's shipping box is going to be 8 times larger than Havana's, or the volume of Jake's shipping box will be 8 times larger than Havana's. All right, that's it for lesson 27. Please let me know if you have any questions.